Welcome to today's webinar. The topic today is Introduction to RFEM 6 and RSTAB 9. Today is part 2. We presented part 1 in the last week. If you don't see the part 1, you can watch the recording. It's no problem. The topics today are the combinatorics, design, and documentation. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the Dlubal website, the German and English webinars, customer projects, newsletters, and so on. I will be the moderator and presenter today, and my two colleagues will support me, and they can introduce themselves.
Hello, my name is Oliver Metzges. Here at Dlubal, I'm working as a product and customer support engineer, and today I will answer your questions.
Hello, my name is Markus Baumgartel. I'm responsible for customer support and frequently asked questions on our website. And today I will help my colleagues to answer your questions during this webinar.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screens. For the participants who participate the first time, that's the control panel. You can show that with that arrow here, and then you can enter a question here, and my two colleagues will answer you. Yeah, you can also watch the entire webinar and then email questions to info@dlubal.com. Okay. Yeah, as I already said, all our webinars will be recorded. I start with the content for today. The first step is applying imperfections. Then I will do the load and result combinations. The program will do that automatically, but I go through the different dialogues. Then I design the timber and steel components, and the last point for today is the documentation. Then I open the program. That's the state from the last webinar, from the first part of the webinar that we presented last week. I created this model and the different load cases, self-weight. I go through them both. Snow, 2 wind load cases in Y direction and 2 wind load cases in X direction. I go back, left the both in the base data, what we selected last week. I activated the 2 add-ons, one for steel design and one for the timber design. Also, the combination wizards are checked, and I selected the different Eurocode standards with the German National Annex. And under settings and options, I activated the member representatives and the member set representatives. I would like to design only one representative, for example, and all members that have got the same properties, the same length, for example, same cross-section, are collected in one representative, and I design only one of them. So then the member representatives wizard, all steel and timber design properties are checked, and the same for the member set representatives. Okay, I'll leave the dialog and I start with the applying of the imperfections. On the left side, you can see the navigator data and then the folder imperfections. And at first I have to select or create an imperfection case. I can do that with a right click and then new imperfection case. The imperfection case collects the imperfections. After the creation of the imperfection case, I need to create the imperfections. the main advantage of the imperfection case is that you can create a group of imperfection cases. That's, for example, necessary for buckling design according to GMNER method. And that's the main advantage. So I create the imperfection case imp y and assign this imperfection case to the wind load case 3 and 4, the two load cases with the same direction, y. So then left on the bottom, I check create new imperfection case. I call it imp x and assign the wind load cases in x direction. And you can see in the combinations, in the background, the combinations are created automatically, and you see only the combinations with wind load case 5 and 6, and not with load case 3 and 4 anymore. Now you can check that here. Same for imperfection y. You can't see any combination with the wind load cases 5 and 6. Only with 3 and 4, and of course the other load cases, load case 1 and load case 2, the snow load wind case, snow load case. Okay, I leave the dialog, and then if I go to the navigator data, I can open the local imperfections, and for example under the folder imp y, I can create a new member imperfection. Now with a right click on it, can I select new member imperfection. The other way is to go above here and select the button new member imperfection. So the right imperfection case is selected. I would like to create an initial sway. I would like to assign the initial sway to the steel columns, and I will use for the steel design the equivalent member method in combination with imperfections and calculation according second order theory. That's sufficient for the design according to the equivalent member method. Okay, this definition type, Eurocode 3. So the coordinate system is local set. Okay, I forgot to show the member axis systems. I select Y. I know that from the test. So then I measure the structure height. Measure. I measure the longer column. Doesn't matter that this column is a little bit shorter. 2 columns should be in one row. This one and this one. And I can select or press OK. And I need to select the different. Okay, I must go in the dialog again. But before I do that, I go in the navigator display. So, and then under members, you can find the member axis system. So now you can see the local member axis system. So, and now I go or turn back to the navigator data, double click on the initial sway, and you can see the local Y direction this direction is it's the same as the global y direction. So, and I assign the different columns. Okay. So, and I have to select this button above, show imperfections. So the imperfections are created correctly. So then the next imperfection, new member imperfection. This time I have to select the imperfection case 2 in X. Again, initial sway according to Eurocode 3. This time imperfection direction Z. You can see this is the local Z direction. It's the same direction as the global X direction. Structure height is 3 and 3 columns in one row. Okay, and I select the different columns. So I select the other imperfection case, and you can see that the imperfections are defined correctly. Okay, then we can turn to the load cases and combinations. Here left, on the left side, navigator data. I right click on it and open the load cases and combinations. That's what we defined in the base data, the Eurocode 0 and the German national annex, and of course the base and timber, because parts of the construction are from timber. And when I edit the parameters of the national annex, I can see the KDEF factor. It's the service class 2 and it's 0.8. Okay, so the combination wizard is selected or is activated. Those are our load cases in the next dialog, then the actions. Yeah, and for the wind load cases, it's important that the alternatively action type is activated. It's done automatically. You can see the 4 different wind load cases. That we don't have, for example, more than one wind load case in one load combination. Then the design situations, 1 for the ultimate limit state design and 5 for the serviceability limit state design. Then or if you click on one of it, then you can go to the overview and can see the different assigned load combinations. And in this dialog, you select you activate the add-ons. You can also concrete design or can assign concrete design. If you activate the add-on, we activate, for example, for the ultimate limit state design, the steel design and timber design add-on. Let's go to the action combinations. And it's the important thing, the load combinations for ultimate limit state design and serviceability limit state design. At the moment, we have got 60 load combinations. Let's go back to the design situations. Yeah, of course, we will activate the steel and timber design for the ultimate limit state design. For the design situation number 2, the serviceability limit state design characteristic, we also activate steel design and timber design. Yeah, that's all for the steel design. And we check if we need this serviceability limit state design quasi-permanent for the timber design, I go to the info button, and you can see in the combination rules, you can see the KDEF factor, what's quite important for the timber combinations. That's why we need this design situation for the timber design. You can leave the dialog, uncheck the steel design. We check the same for the design situation number 4, information, and we can see the KDEF factor again. That's why we need it also for the timber design. And we don't need it for the frequent base. And you can see the KDEF factor, and you can see the KDEF factor here. So that's why I delete these 2 design situations. Okay. So again, this design situation for both, this for both, design situation 3 for timber design, and 4 also for timber design. So with the Shift key, I select the 3 serviceability limit state design situations and check the geometrical linear analysis. And for the ultimate limit state design, the second order theory. Okay. So now we go back to the load combinations, and you can see there are 45 load combinations. Let me check if all is correct. Yeah, all should be correct. So that's all for the combinations. I go back to the navigator data. I deselect the member access systems, but I select or show the member representatives and the member set representatives. I hope you can see it. I go right above to the wireframe model button. You can see these 3 columns are in a group, in the same group. It's the same member representative, and that's member representative number 4. Now you can see that in the different color of the points in the middle of the member. So I go left on the bottom in the navigator data to the member representatives and the member set representatives. So that's the timber representatives. You can see that's the cantilever beam, and that's the inner beam here. And I start with this inner beam made of timber. Okay, then I go to the design type. You can see the service class number 1. That's not correct. I added the service class with that button and change the service class to moist. You can see this preview image. That's what valid for our structure. You can see the timber structure on the outside, but there's a roof over the timber structure. That's the case for our structure. Okay. I don't define any effective lengths. We don't do stability analysis for the timber beams. I assume that I've got formwork, nailed formwork of timber on the upper side of the purlins, or a stiff plate nailed on the upper side of the purlins. And it should be quite stiff. So I go to the design situation, ultimate configuration, and select the edit ultimate configuration, and I uncheck the stability analysis. Okay, and yeah, we leave the standard parameters. I apply with OK. So I go back to the design situation and serviceability configuration. I press the edit button, and I leave the parameters from the standard. Okay, and we don't perform any fire resistance design. So the next dialog is the design supports and deflection. Now I have to enter a support at the member start and the member end. I press this button, create new design support for member start. The type is timber. Direct support. The support length is 160 millimeters. Yeah, that's the width of the steel beam, the HEA 160. The support width is equal to the width of the member, of the timber member. If you change the width of the timber member later, it will be calculated automatically or changed automatically. It's an inner support. We do the design only one time for this member and not for the cantilever beam. And we say it's an inner support. That the program uses the complete length or the complete width of the support. In our case, the steel member. So I need to define the factor of compression. I select 1.5 softwood discrete supports. Okay. So it's only supported in Z direction. Okay. So the design support should at the member start and the member end. Okay. Yeah, that should be all for the timber design, but I checked the beam number 3, the cantilever beam. Design types, the same service class, 2, the same design configurations, no fire resistance design, and we don't need to define any support. We design the support with the beam number or the member representative 4. Okay, that's all for timber. I can run the calculation here in the table on the bottom, steel design, timber design, sorry. And I press this button, show results. And this runs the calculation. Program calculates all combinations, but simultaneously, it's a new feature in RFEM 6, a multi-core calculation. My computer has more than one core. That's why the combinations are calculating in parallel. So I show the design ratio on members. You can see the different design ratios. 68% for the serviceability limit state design. No, the maximum is 83 for the serviceability limit state design. If you double click on the line, a new table is opened. You can see the design formulas, also the equations from the standard. Let me select another one, maybe a section proof, for example, this. I can double click on the line, or I can use that button, design check details, and you can see the equations and the equations from the standard. Complete design. And you can print it directly with that button, print graphics to printer, and printer graphics to print out report. A very nice new feature of RFEM 6, often wished from our customers, and we implemented it for RFEM 6. So, okay, that's all for the timber design. We continue with the steel design. I select the member representatives 1 and 2 and do a right click, edit. That's those the columns. You can see them on the cross section. Design types. I select the effective lengths. I will, as I already said, I will use the equivalent member method. That's why I have to create effective lengths. And another way would be to use the general design method. Then you need to define boundary conditions. So I create a new effective length. All the flexural buckling and torsional buckling should be designed. I check all. So, and I leave the member lengths by 1. The effective length factors, SK, should be equal than the member lengths. Because I assigned imperfections and used the second order theory for the ultimate limit state design, that's sufficient if I leave the member lengths to 1. Okay. So then design configuration, default. I go to the edit button. I perform a stability design and I leave all checks as they are. Apply with OK. Serviceability configurations, let me check it with the edit button. And I leave the standard parameters as they are. Okay. And I don't do a fire resistant design. So then design supports. I have to create a design support at the member start. I see it as a cantilever column, what is rigid supported at the member start. So new design support, general support, and I leave all parameters as they are, but I select it for both directions, for the Z axis and the local Y axis. Okay, but only at the member start. You can see that in the preview. So that's all for the member representatives. You can leave the dialog. All results are deleted. And I continue. I deselect the results. So I continue with the member set representatives. These two sets of members are contained. I double click on it. So, and I can see where are no design tabs here. I leave the dialog and I select the member sets, or they are selected. I double click on one and I have to check or set this check here, design properties. Now it would be also possible to enter here the design types, the design configurations, and so on. But yeah, I will use the member set representatives. I'll leave the dialog. Double click on it. Select the design types. I will use the equivalent member method again. Create a new effective length. Nodal supports and effective lengths. So, and with this button, I select one set of member. And I can see there are only 3 inner nodes, and that's not correct. I leave the dialog. Okay, I can see only 3 nodes. We check why. As I copied the Perlin in the first part of the webinar, the member wasn't divided. And now, this node is missing for my set of member. So I'll correct that. I use this function here right above, connect selected lines, members, and so on. I select it. Okay. So, and select this member and this member. Okay. And now the member is divided. There are only 1 meters or members with a length of 1 meter, but the member set is still the whole beam, or all the beams are collected in 1 member set. Same on the other side. Okay, I turn back to the member set representative, double click on it. So go to turn to the design types, and I edit the effective length. Click on 1 member set again. So now our inner supports are here. I can open the preview here on the bottom. You can see the 2 member sets. And now I can select more than 1 node and assign the different support directions and so on. So I can use that button, select nodes. I do that for only 1 set of member. So this node, these inner nodes, these inner nodes, and this node. Okay, all are selected, and I check only the support in Y direction. You can see in the preview that this is okay. And now I use this function again, select nodes. I select this node over the column, the 3 nodes over the columns. Okay. it should be fixed in Z, Y direction and about the X-axis. Should be a Gable support. So, and now all is correct for both sets of members. And we collected in one member representative. I can leave the dialog with OK. And you can see in the preview again that all is defined correctly. So then design configurations. Yeah, we leave the same configurations for the ultimate limit state design and for the serviceability limit state design, and we don't perform any fire resistance design. Okay, then we have to define supports or design supports. At this point, use the general design support in this point over the column and in this node over the column. And we check the direction. It should be only designed, or the serviceability limit state design should be performed only in Z-axis, because we have the stiff purlins and plates on the upper side of the cross section. Okay, that's all. We can leave the dialog and run the steel design calculation. Press this button here on the table. Okay. All load combinations need to be calculated again, but with the multi-core calculation, that's no problem. Okay. Now you can see our results for the steel design. Let's go to the table, design ratios on members. So the maximum value is 49%. Yeah, it's the deflection in Y direction, global Y direction for the column. Okay. So let's select design ratios. Oh, just a moment. Design ratio on members, it's okay. By cross section, let me check. I can do that with the member representatives. Design ratios by section. That's the column. Okay, and member set representatives by section. That's the horizontal beam, and you can see the maximum design ratio. It's about 25%. I think a smaller cross section is sufficient. Let me go back to the navigator data. You can see the sections here. And I can right click on the HEA 160 and edit it. Now with that button, I go to the library, then standardized I-beams, H-beams, and then HE 120A should be sufficient. So that's all, but you need to consider that we need to modify the design support, because the support length isn't 160 millimeters anymore. Now we have got 120 millimeters. And it's now correct for all design supports. Okay. Okay, then we run the calculation again. With that button, you can run all calculations, the load combinations, design situations, and the steel and timber design in our case. So then let's check the design ratios. Steel design. Here, design ratios by section. The column, almost 100% for the serviceability, limit state design, and the horizontal beam has got design ratio of almost 50%. Maybe we can optimize the column, or not the column, but the horizontal beam, but I leave it as it is, the construction. So, okay, that's all for the design. Now we will create a printout report. At first, I would like to print the steel design graphic and the timber design graphic in the printout report directly. Let me switch off the design supports. I turn to the navigator display. And sometimes you can't find any part of your structure if you want to deactivate it or to disable it, and you can find it. Then I have got a tip. When you do a right click on the, for example, for the design support, then you check the display properties. So, and those are the properties for the design support. But what I need is the structure of the folders. Where can I find the design supports? And you can see you can find it under the types for members. And it has got nearly the same structure as in the navigator display. Types for members. You can leave the dialog. Types for members, and you can see the design supports, and I can uncheck it. So, okay, let me print this graphic. Left above, you can find this button. You can print the graphics directly to the printer, to a PDF, or to a 3D PDF. I use the function print graphics to print out report. I check current only. It's already rotated. That's 0 degrees. And I would like to rotate it clockwise 270 degrees. Okay. I press OK. And now the printout report manager was opened. I have to enter a name, printout report 1, and can check the different report items. Let me go through them. I leave the first entries. Maybe we check the loads for the different load cases. That's quite new in RFEM 6, the parts list. Let me print some parts list or lists. So we leave the static analysis results. Then there's the folder for the steel design. Let me increase the window. That's also a new feature of RFEM 6. So, and I would like to print only the design ratio on representatives by sections or by section. So I uncheck the others. So, okay. So, okay. So, and design ratio on member set representatives by section. So then timber design, the same. Design ratio on member representatives by section. Oh, that's sufficient. Okay, we can leave the dialog. We don't open the printout report. It was, parts of it were created. We print the next graphic manually. Here, timber design, left above, and the navigator results. The ratio envelope. So I move it a little bit and go above to the print graphics to printout report. Same workflow, same rotation. Okay. So, and now we would like to use the isometric view for a multi-print. I select print graphics to printout report again. And I select the option multi-print. And now you can see different dialogues on the top. Model. We would like to print the isometric view of the model, the current view. Then imperfections. I select them all, means 2 imperfections, the current view. Loads. Not all items. I select the 6 load cases. Okay. Current view. You can also check other views, in our case without imperfections. That's also only an example. You can print what you want, but I would like to show you how you can print several graphics in one step. So load case and combinations. I select only the design situation number 1. I'll remove the load case with that button, and I select the design situation number 1. Okay. Current view, members, internal forces, only as an example, N, V, and M graphics. Okay. Now we don't print the add-on graphics. I printed only the 2 add-on graphics manually. So, and we can see on the bottom that there are 14 graphics. Now if I go back to the general view, so you can see the previews of the different pages, the model, imperfections, and the loads. Okay, now I press save and show, and the printout report with all graphics is created in several in some seconds. Okay, that's the printout report. A new important new feature is that you can work in the printout report and in the model in parallel. Yeah, I can show that on like this on one screen. A new important feature. So, and let me show the different graphics. They are on the right place. The model under the base data folder. Then the imperfection graphic under the imperfection case and under the local imperfections. Okay. Then the different load cases under the loads. Okay. Then under static analysis results, you can see the different graphics. N, V, and M. So, and under the folder timber design, for example, you can see the timber design graphic. And I skipped the steel design. That's the graphic for the steel design. So before the graphic, you can see the tables with the results of the design. Okay, let me show you the parts list. Yeah, parts list member by material overview. This graphic. I can zoom a little bit in with the control key and the mouse wheel, for example, or with the buttons above. Zoom out and zoom in. Oh, that's all okay. Yeah, and you can see the different lengths of the members, the sum of the steel parts and the timber parts, and the sum of all the unit surface area, for example, and the unit mass, and so on. Okay. So then let me turn back to the cover. It's the start of the printout report. You can modify the cover, you can enter a client and so on. I right click in the menu here, press edit. You can select the preview image or deselect it. I enter a client, John Doe, created by me, Harold, and the project, we call it roof on market. So, okay. That should be all, or we don't call it roof, we call it shelter. Shelter on market, okay. So then you've got other settings. For example, you can enter your company name here. You can upload a logo. That's the Dlubal logo. And do a page setup, printer settings, and so on. Okay, that should be all. I leave the dialog. Okay, the value from my printer is not enough. That should be okay. Okay. So now you can see the modified cover with the text. So I go to the menu. You can insert different things, a file, image from clipboard, plain text, rich text, HTML, formulas, PDF. Now let me show you how to insert a plain text and a PDF. It's always the same workflow. I insert a plain text. I call it preliminary notes. Okay. Enter imagine text here. Should be okay. Okay. And it's added at the end of the printout report. You can see the preliminary notes. So, and I moved the item to the document start. So that's the content, and you can see the preliminary notes here. Okay, let me go back to it. Oh, it's okay. So you can enter properties, so it can change the text anytime. Okay. Then I insert a PDF. So from my desktop, I prepared a PDF from our GeoZone tool. I think you know that from our website. I can enter all pages or a selection of the different pages. I enter the OK button. So I press the OK button, and then the PDF has been added at the end of the printout report. I can move that, for example, also with drag and drop. Let me do that. I close these folders and I move the PDF before the load wizards. Okay. So now you can see the PDF here. And then the load wizards follows. Now also with the location and so on. Okay. Then edit. Okay, that's also quite important. You can set a language. You can translate, or the program can translate the printout report in 10 different languages. It takes only some seconds to translate such a printout report, for example, in French, Spanish, German, etc. Then report. You can print the report directly, or export it to PDF or to an HTML. Let me export it to PDF. To my desktop, PR1, printout report 1. I save it. The PDF is creating, and I open it. So, okay. You can jump between the different chapters on the right side. All tables and sheets and graphics are printed in the PDF. Okay, yeah, that should be all for the presentation. I would like to show you where you can find the recording and today's model and the PowerPoint slides. Before I do that, I have one hint. If you want to book a free online presentation of our add-on or programs, or add-ons or program, RFEM6, RSTAB 9, and so on, just book your free appointment, and then you need to contact our sales team with that button here, or you can scan that QR code. You can ask for a non-binding offer, for example. Feel free to contact our sales team. So let me open our website, dlubal.com, and under news and events, you find our webinars. That's the webinar of next week. I will present that as well, together with Markus Baumgartel. Then the week after next week, we present the FRC design of a concrete design. So that's today's webinar. I click on it. In the next days, you will get an email with a link to that page. You will get your attendee certificate. Then you will see the recording here in the middle. You can already find the presentation slides and the model. That's the model from the German webinar that I presented beginning this week. Okay, yeah, that should be all for today. I thank you for your attention. Thanks to my two colleagues for answering the questions. Maybe a last wish: when you leave the webinar, there's a small survey. It takes you only 1 minute. You can enter wish for future webinars, for example, but you don't need to do that. But you can score the webinar. Just note that the worst score is 1 and the best score is 5. That would be very nice if you take the time. Okay, thank you for all. Maybe we meet each other in a future webinar. Would be very fine. Bye-bye.